Hello everyone, welcome to Brain Blitz Audios. Today we're looking at the chapter Electricity. It is the 12th chapter in your science syllabus for grade 10 Cbse. To make this chapter more interesting and easy to learn, we're taking the help of this mind map. Mind maps are very effective tools for easy revision and last minute preparations. Now we divide this mind map into 6 portions. The first part deals with the types of circuit, while the second is about circuit diagrams. The third part deals with resistance and Ohm's law. The fourth part deals with resistivity and Joule's law. The fifth part deals with power and its unit. And at the end, we put in some precautions of handling electrical appliances. Let's begin, shall we? Now, types of circuit. What do you mean by the word circuit? A circuit is a closed path through which an electric current flows. Now, circuits in electricity are divided into two parts: parallel circuits and series circuits. A parallel circuit contains electrical components such as bulbs in parallel to the battery or the source of power. In a series, the electrical components such as resistors, bulbs, etc. are connected together in a series. Now, a circuit or a closed path is represented in various symbols and components. Here are some of the symbols of an electric circuit. The 4 vertical lines here represents a dry cell. The cell is the electrical component which provides the necessary potential difference to an electric circuit. The wire of an electric circuit is represented by a single straight line. A switch is represented in this way, and a bulb is represented hence. To find out more such representations, let's go to the next part of our mind map: circuit diagrams. The jagged line with an arrow on top or crossing it is known as a variable resistance or rheostat. The representation of a jagged line in an electric circuit represents a common resistor. Now, when 2 wires cross each other without any contact, it is represented by a wire crossing. If a joint between 2 or more wires is present in a circuit, we represent it with this wire joint. A switch is represented by this diagram, and if it's on, we put a period inside the bracket. A normal cell is represented here with 2 vertical lines parallel to each other, one of them bigger than the other, the bigger line being positive terminal and the smaller line being the negative terminal. Now, let's move on to one of the most important parts of this chapter: Ohm's law and resistance. A scientist named George Ohm has found out that the potential difference in an electric circuit is proportional to the electric current flowing in that circuit. He used the relation V is proportional to I. And from there, we get the statement for Ohm's law. V is equal to IR. R is the constant of proportionality. Now, Ohm's law is applicable only if the temperature around the conducting ends of the electric circuit is the same. Let's learn more about this constant. The constant in Ohm's law is referred to as the resistance of a wire. It refers to the resistance that a charge faces when flowing through a conductor. Resistance, using Ohm's law, can be represented as R is equal to V by I, where V stands for potential difference of the circuit and I stands for the electric current. Just like circuits, resistances can be kept in parallel or in series. A series resistance contains two or more resistors connected to each other in series. The total resistance of a series circuit will be equal to the sum of the individual resistances. Suppose a system has resistors in parallel circuit. It is referred to as a resistance in parallel. In a resistance in parallel, the reciprocal of the total resistance of the system is equal to the sum of the reciprocals of all the individual resistors. Now, let's move on to some more aspects of resistance, such as resistivity. Now, the resistance of a wire is measured by the following formula. R is equal to rho L by A. L stands for the length, A stands for the area of cross-section, and this symbol, rho, stands for the resistivity of a wire. The value of resistivity varies with the material being used in the wire. Therefore, copper, aluminum, steel, etc. have different values for resistivity. Let's jump towards Joule's law of heating. According to Joule's law of heating, the heat emanated by an electric circuit is described by the formula H is equal to VIT. Now, V stands for potential difference, I stands for the electric current, and T stands for time. Now, V into I can be represented by the power of the circuit, or P. Therefore, the heat of the electric circuit can be represented as P into T. It can also be represented as I square RT. I stands for electric current and R stands for the resistance of the wire. The unit of heat, like the unit of energy, is joules. So we measure the heat of an electric circuit in joules. Now, let's move on to the next topic. Power of an electric circuit. Power is represented as the rate of formation of heat or energy. Therefore, power in regular parlance is energy or work divided by time. Therefore, electric power is represented as I square R, VI, V square by R, etc., where I stands for the electric current, V stands for potential difference, and R stands for the resistance of the wire. Power is defined as the rate at which electrical energy is dissipated. This definition is specific to electric power, and we measure power using the SI unit watt. which is named after James Watt, who invented the steam engine. Now, let's move on to the final part of this mind map: precautions for handling electrical appliances. Now, electricity is a very wonderful phenomenon. However, it can be dangerous to us humans too. The precautions are against the danger of mishandling electrical appliances. If we mishandle electrical appliances, we are at a risk of fire by short circuiting, burns, electrical shock, electrocution, etc. Therefore, it's very important to take precautions such as using rubber gloves while working with electrical gadgets and using of earthing wires, fuses, etc. And that's all you need to learn from the mind map of this chapter. Let's move on to another efficient way of last-minute revision, which is the flowchart. PD in this flowchart refers to the potential difference. Its formula is work done divided by charge, and it is measured in volts. Ohm's law states that V is equal to IR, where V is volts, I is the electric current measured in amperes, and R is the resistance measured in ohms. Resistance is also described as potential difference divided by current, again derived from Ohm's law. Therefore, R is equal to V divided by I. Now, resistivity or specific resistance, which, as we said, is different for every material used, can be described as resistance into area of cross-section divided by length. The unit of resistivity is ohm meters. Now, for a resistance in series, the formula of total resistance is the sum of the individual resistances. For a resistance in parallel, the formula for the total reciprocal of resistance is equal to the sum of the reciprocals of the individual resistances. 1 by Rs is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. and so on. Joule's law of heating states that the heat produced by an electric circuit is equal to I square RT or VIT. I stands for the current, V stands for potential difference, and T stands for time. The unit of heat energy is joules. Electrical energy. Work is equal to VIT or I square RT. This is similar to Joule's law of heating. Therefore, heating is a result of electrical energy. We use watt hours or kilowatt hours for commercial units of energy. 1 kilowatt hour is described as 3.6 into 10 raised to 6 joules of energy. Electrical power can be described as work divided by time, or in other formulas, VI, potential difference into electric current, or I square R, electric current squared into resistance. The unit of electric power is watt. This is the SI unit of power. Now let's revisit the symbols that we can use in an electric circuit. A single electric cell is represented like this, while a whole battery is represented like this. A key can be represented in two ways. This is how a rheostat or variable resistance should be represented. A light bulb can be represented in this way. This is how a wire crossing, which does not touch each other, is represented. A single jagged line represents resistance. This is another form of representing variable resistance or rheostat. Ammeter, the device which is used to measure electric current, is represented like this. Voltmeter, the device used to measure electric potential, is represented like this. And for an alternating current source, we use a symbol like this inside a circle to represent it. Now let's look at some of the circuit components. A cell provides potential difference between 2 points. A combination of 2 or more cells connected in series is termed as battery. A bulb glows when electric current is passing through a circuit which is switched on. Resistance controls the current flowing through the circuit. Variable resistance is found in a rheostat. The ammeter measures current flowing through the circuit, while the voltmeter measures the potential difference between 2 points in a circuit. A key is used to open and close the circuit. Some of the safety devices in a circuit include the fuse, a wire which has high resistance and low melting point. Wires are used to connect circuit components, and a galvanometer detects the presence and direction of current in a wire. And that's all you need to know about the chapter Electricity. Now, Brain Blitz Audios has a wide range of content, including stories, mind maps, poems, learner words, etc. Now, we have a mission to impart free education to all. To be a part of our journey, please subscribe to our channel and like this video. We hope you enjoyed the short explanation of the chapter Electricity. Until next time, goodbye.